It's really cool how they do that. I don't think Zoom did that for a long time unless they do it now. Cool. So welcome to Meetup, everybody. I'm glad you all could come. We did have one last month. So I'm going to try and keep this meetup going because we have a whole bunch of awesome speakers to pull from. Josh being one of them. I actually met Josh on Twitter, I think, right? It was like a weird Slack Twitter thing, and then we chatted on Twitter for like a year and a half, and then he ended up working on my team. So I actually know him pretty well after that really awkward meeting, but I meet a lot of people on Twitter. So I'm used to that. But yeah, I can actually give Josh an introduction, but I usually leave it up to them. So I'll let Josh introduce himself, and I just want to remind everybody that we do have a meetup next month, I believe. It will be on something about big data management strategies for big data. So it's not quite on the machine. I mean, it's not pure machine learning, but it's very important to anybody who does it. So, yeah. And Matt Housley will be giving that. And if you haven't met him, he is very, very knowledgeable on data infrastructure. So cool. I am going to go ahead and I will turn off my camera and mute myself and turn the time over to Josh so he can share his screen and kick it all off. It's your turn, Josh.
Yeah, awesome. Can you hear me? Cool. Let me steal the screen. Look at that. I have to open my system preferences to allow Chrome to use my screen. I knew something would go wrong.
Is this what happens when you don't use your work computer or you use your
Yes.
different account?
Yes. Okay. Now,
Where'd it go? He'll come back. That's really funny. We should have tested that before, but we use Google Meet all the time at work, so I figured he'd have everything ready to go. Welcome back, Josh.
I'm back. Let's see if it'll let me share my screen. All right. So,
I don't see your screen.
Yeah.
There we go.
Okay, sorry. I thought I had adequately prepared, but apparently in this world, there is no adequate preparation. Okay. So I'm assuming everyone can see this screen. I'm going to super enlarge it and assume that you can all see the screen. If not, someone yell at me. As a brief intro, my connection with AI goes way back, back into my undergraduate college days. And it's, I'm probably more on the side of the philosophy and history and kind of mathematical backgrounds of artificial intelligence and machine learning than I am in, you know, implementing code and systems at like massive, crazy scale. And so, not that I haven't done a lot with it that way, but And I've always been on the periphery of the AI world, which, you know, I used to hate and it used to drive me crazy, but now I see it as a kind of an interesting, having given me an interesting perspective. So one example, natural language processing. I have a background in linguistics, theoretical linguistics, computational linguistics, Native American linguistics. And I was always studying languages that had nothing to do with English at all. And NLP, up until very, very recently, has pretty much just been English specific. So I was always on the periphery being like, wait, no, that's not really a good way to do it, because, you know, there's all these thousands of languages that, or hundreds of languages that won't work for. So today, you know, I can't really ask you to raise your hands. But I'm assuming you might have heard the term democratizing AI. And if not, we're going to get into that, and then hopefully we can have some discussion. And as Mariah was saying, feel free to interrupt at any point through this. So this is not a tutorial, and it's also not like a university lecture. So like, have at it. Democratizing AI is a term that, you know, just kind of, I started noticing get used in the last couple of years, and I'd never seen it or heard it before. So it's a fairly kind of, I think, a fairly recent term. That's just based on my own kind of, you know, small sample size observation. But generally, right, when we get into democratizing AI, we're talking about two main fields. One is knowledge, one is execution. And just as a tangent, sorry, if my audio or video breaks down any time through this, please, yeah, just interrupt. So the first sense of democratizing AI, right? And you can go Google search this now, and you'll get all kinds of hits and journalists writing about it. And like Microsoft has got a whole series of case studies of democratizing AI. So the first thing, right, that we're going to, you know, is knowledge, teaching. Just teach everybody AI, and it will just spread all over. And so there's plenty of open source, free courses, so Coursera and Udacity, both started actually as experiments to try and start teaching more people machine learning, and then grew into full-on, you know, Silicon Valley startups. And I remember when they both were actual just experiments of trying to take Peter Norvig and Sebastian Thrun, and for Udacity, and then it was Daphne Kohler and Andrew Ng for Coursera. They were just trying to make more accessible their courses related to AI and machine learning and things like that. And so Coursera, Udacity have grown up. They obviously now they have, you can get certificates, you can do full-on plans. They've paired with universities, right? And then the other main course, the other main path for education is college and university. There's tons and tons of other resources, right? So platforms and services is more the execution part of let's execute AI for everyone, or let's, you know, make it run for everybody and make it available that way to non-experts. Right? And so one is like, oh, we'll just build expertise from people who may not have a total background. Fast AI. Oh, I should have added Fast AI because they're a little different. You may have heard of them. And that's Rachel.
I like Fast AI. I think theirs is super cool.
Yeah, they actually have, I think, probably one of the most like developer, like if you're already a professional developer, and anyways, yeah, I really like what they've done. Gosh, I can't remember the last names and then the name of the other person who's involved with that. But they've done a tremendous job, and they had a really cool logo or a really cool mantra when they first started. It was making neural nets uncool again. So I thought that was pretty funny because like it's kind of a historical joke because neural networks came around like the late 1940s, 1950s, and there was a lot of hope and cool promise, and then they just like became the laughing stock of a lot of people, and so much to the point that they changed the name and they started calling it like parallel distributed processing, and they started calling it other things because literally saying neural networks, like people would laugh at you. So I think embedded in that little mantra, making neural networks uncool again, is kind of I don't know, a little jab of that. Yeah, thank you for posting that in the chat. Yes, Richard Thomas and Jeremy Howard. Yeah, cool. And they both have they have academic histories, and they I don't know if they still currently teach as of now, but they were teaching at San Francisco State University. But they also have tons and tons of like industry experience. So I think that's kind of what distinguishes their way of trying to educate versus something like a Coursera or a Udacity. So moving out of the education, platforms and services is the other way. So instead of building expertise, we just want to deliver, kind of black box expertise to non-experts. And so platforms and services, open source projects, so TensorFlow. I remember when TensorFlow was open source by Google, it was like, people were literally questioning whether that was a good thing or not. It was a big deal. Certain classification services, data services, even something like Pachyderm, if you're familiar with that company. And there's a lot of other kind of more, deploy your model, deploy your AI types of services. And even into the hardware world, where Google invented, created, patented the tensor processing unit, the TPU. A processing unit built specifically to handle the kind of kind of linear algebra mathematics that needs to that a lot of deep learning workloads need. So Google Cloud Platform, Amazon Web Services, Microsoft Azure, right? So the big names all have invested who knows how much at this point. It is worth noting though that, all three of these companies, even though they specialize in AI now, you could very easily classify them as having always been AI or machine learning companies. And the reason for that, I would like to, hopefully it'll be more clear later on, why these companies didn't just suddenly pivot into being AI or ML companies. They kind of always were. But now they've made it a particular business goal. So the pessimist for democratizing AI very much is like, okay, let's look at how much research and development, how much investment, marketing has gone in to just trying to tell you, hey, use AI, use ML, and by the way, our service will do it for you. Right? I mean, these are massive enterprises, Google, Amazon, Microsoft. They're not going to spend that amount of time and energy and money into platforms and services and skill and talent and open source code if they didn't think that there was some very, very, very big payoff for them, right? Otherwise, why else would they be doing it? So the pessimist view is like, oh, democratize AI is really just all marketing speak. Much like, if you remember, if you ever got to see IBM's cognitive computing thing, that was very much all kind of marketing. And I actually had a friend who worked in the Watson question and answer team, and his stories were pretty bad. One day I just asked him, I was like, dude, what is up with IBM's push on cognitive computing? And his answer was pretty much, well, it was actually kind of a thing, and then the sales and marketing people got let loose on Watson and all this stuff, and it came out of there. So the pessimist view on democratizing AI is that really it's a lot of marketing. The optimist view, right, is that, hey, we're gonna transform society. So Andrew Ng, if you listen to him talk, AI is the new electricity, or when you hear people saying other similar types of things, right, that's very much like the optimist view. Right, and so Andrew Ng's metaphor, right, is that, well, people were scared of electricity. They thought it would ruin rural jobs, which it did, right? And people were scared that it would kill them, and electricity did kill people. It would electrocute them, right? And it just kind of got let loose and was wild, and then it grew and matured, and now we can't do without it, right? But in order for it to actually work, you had to have this wide adoption in both non-expert use and adoption of electricity, but also you now had to transfer a bunch of skilled knowledge workers into being electricity specialists, right? And which is still pretty much the way it is today, right? Though that talent pool of skilled electricity people is probably much smaller than the number of people who are non-electricity specialists, like me. I just turn my lights on and it works, great. Right? So I think that's kind of where Andrew Ng is with this optimist view. Democratizing AI, it's a way to revolutionize essentially human history and society. And what we need to do though is we just need to build adoption with expert and non-expert at the same time. So great, let's build stuff now that I'm democratized, right? So let's use APIs, right? So this is very much on the executor side, right? Of okay, I'm a non-specialist and I just want to use it. So consuming an API, right? We're assuming you're already a professional developer, but maybe you're a non-specialist ML or AI person, and you just want to consume an API to do some kind of classification on some data in your website, right? So the good, easy to use, right? You don't really need any expertise to get started, right? Outside of maybe some tutorials and how to use the API and all that other stuff, but not much different than any other kind of like service integration, right? Third-party service integration. Maybe there's some new concepts, but I thought you're kind of at a very, very high level in terms of how to use it. And it works, with existing products and APIs. So if you've got a Node app, if you've got a Go app, doesn't really matter what tech stack you're on. If you're consuming, an AI service or a machine learning service via an API, right? That protocol is essentially the standard for communicating across non-expert to expert. Okay, so what's the bad, right? APIs can be expensive, like really expensive, like really, really expensive. They're hard to retrain the data and debug. In many cases, you don't even really get to use a whole lot of training data. You can maybe upload training data, and many services allow you to do that, but it's not really clear to you, how much of that data is used or what is, how it's being used. And of course, years and years ago when I was I had developer access to some of the Google APIs when they were first releasing them, so Bigtable, when Bigtable first came out, and some other things. And I went to the VP of marketing and some other people around the company, and I said, hey, this is cool. Let's go do this. Let's go try this. And they're like, how does it work? And I said, well, I have to upload some of the data into there, and then once it's there, I can go and try and use these services. And they flipped, right? They were like, what? No, you're not giving Google our data. So there's that problem of you're kind of giving away your data in a way, but also in a more practical sense, it can be very difficult to know, how is it being trained, what's being used, what are the, what are the choices that were made, and then of course debugging it. If all you're getting back is a label and like a ranking score or a confidence interval for the classification, it's very difficult to know how those were gotten it. So they're also built a lot for general solutions, and so not your specific business domain, right? And this is something I run into a lot, where a lot of people think, oh, well, it's just our business, and it's just the data in our business, and it's just data. But the more you dig into it, the more you realize that even companies that are in the same kind of market, their data can look very, very different. It can be very, very, very different, and the requirements that you want, or the requirements that you have to make decisions on your data can be very, very, can be dramatically different, even from someone in the same market as you. And so when you're consuming an API that is just kind of built for, like, say, general cat and dog and or hot dog classification, right? You're like, okay, yeah, but we don't really do hot dogs. We're Jimmy Dean, and we build sausages, and we need to be able to classify the difference between the cheese-filled sausage and the not cheese-filled sausage, right? And all you have is an API that's like, well, it's a hot dog, or it's not. And so you're like, oh. So then you're going to use it and then try and hack it after the fact or something like that. So, and in fact, somebody from Google, I can't remember the VP's name, at some point was kind of shopping around for a while, getting some consensus building in the PR world a couple of years ago about this notion of, like, listen, for Google, we try to solve these massive generic problems for machine learning and deal with optimization of enterprise scale problems. And as a small or normal or medium-sized business, you have these kind of niche issues. And so that's where that's where we complement, where we give you the big tools, and then you use our big tools to kind of craft a more niche product. And I don't know if they still do that. I don't know if that's still their marketing pitch or if that's still a thing, but it made a lot of sense at the time. Okay, so what if we're going to do a Greenfield project, right? And so we've been acquiring some knowledge. We've taken some Coursera or some Udacity courses, or the Amazon ones, or any of these tutorials, or read books, and we're ready, right? So we get this Greenfield project. The good part is we get to control our training data, right? One of the issues we might have had with an API. And as I hinted at before, you actually start to learn a lot more about the business and the data in the business, to the effect that you can even have side effects where, right, you start finding more things that maybe analytics could be using or finance could be using, because you're forced essentially to become the domain expert, right? Or at least begin to pull together domain experts on business data, right? And oh, great, we get Python and C++, because they have all the packages. They have everything you ever need, like scikit-learn. If you just want to get something up and running and working, that's your best friend, right? So Greenfield project, the bad. Well, training data is also bad, right? You have to clean it, you have to process it, you have to deal with it, you have to, you have to do, I know deep learning, it's popular to say you don't have to do any feature engineering, but you still have to do feature engineering. You just don't have to do as much. And feature engineering meaning, like you're trying to pull out all the different pieces of data, and you're trying to to scale them properly so that you're not sending integers and floats and floating point numerals, or that you're not comparing, you know, ranges of 100 to 200 with ranges of 2 to 5 and things like that, right? Where you're just trying to normalize data, you're trying to strip out, you know, lame, broken HTML tags or something, stuff like that, right? That can sink a project. It often does sink a project, mostly because of the upstream problems in the business where the data gets sent to you and it's all crap and there's no way to fix it. So training data, domain knowledge with the business data, that's a problem too, right? Because if you don't have the domain knowledge or nobody else does, you have to acquire it. And then of course, Python and C++. Have fun optimizing in C++, right? Have fun optimizing your Python when you're chugging over. When you move from being like, oh, we just looked at like, you know, 500 megs of data, great. And now you're looking at like 6 gig of data and the process takes all night to run. You're like, oh, whoops. Well, we kind of needed to run within an hour, not all night. And also a thing that doesn't get mentioned a lot, I won't really dig into it, is managing types. This can be an absolute nightmare, pretty much in, you know, in anything, but particularly with Python and the C++ wrappers. It can be very difficult to have to manage the types between maybe some of the business level code and like the type system you get at the lower level C++, TensorFlow stuff, right? So if you've ever worked with TensorFlow, you know there's only a few types you get to push in to the execution of your graph. And so if you have custom types in Python, you now have to, you know, transform those, and it's particularly challenging when you now have to optimize both your Python and your C++, and you're just, you know, running into a lot of typecasting this to that, and so ironically enough, the bad are all the same things that are the good when it comes to a Greenfield project. Notice that wasn't an accident. That was intentional. The same things that make a Greenfield project, Greenfield ML or AI project good, are the same things that make it bad. Okay, so let's look at some AI history real quick. The 40s to the 70s, roughly, we get Fortran, Lisp, Russia. Nobody would have thought Russia. U.S. Department of Defense and DARPA, the Air Force. So there's a big push in formal logic. There's a big push in a lot of linear algebra. There's a big push in making math computerizable, computerable, computable on an actual, you know, device. And a lot of research and work in floating point precision and how that actually is supposed to work on a computer, right? So if you've done calculus and limits, right? Well, you know, infinity. You don't get to have infinity on a computer, right? So you have to do something. So there's a lot of like math, formal logic, and linear algebra, you know, calculus and floating point precision. And then the programming languages that are around, they get more expressive. Dartmouth College Workshop in 1956, if you don't know that, that's essentially was this big workshop where they got all these different people, psychologists, linguists, engineers, mathematicians, pulled all these people in and said, hey, let's do this new cool thing. And they kind of landed on artificial intelligence as a term, computational intelligence. There were other terms that were thrown around. In around the 60s and 70s, the term knowledge engineering as a concept takes hold and never lets go. Knowledge engineering is still around. It's just maybe called some different things. I see feature engineering also as knowledge engineering. And then US funding, like government funded projects in academia, like skyrockets. And this is a little known fact, maybe people don't, I don't know, maybe it's well known now, but there was this initiative within the government to say, oh, we're in a Cold War. We need to be able to translate Russian scientific journals, and we need to be able to translate them real quick. and automatically, because that would be awesome, because then we could rifle through everything. And so the estimates, funny enough, at the time, between engineers and whoever else was involved in these discussions, was maybe 1 to 2 years. So, and if you know much about machine translation, we're still, I mean, we do okay, but we're not even close. So the 70s to the 2000s, probability rises, the use of Java, the use of Python rises. So rules-based systems, they begin to give way. So originally, all this movement from mathematical logic, which was also the founding of a lot of the kind of formalizing of how to do logic gates, and led into things like information theory, and really kind of foundational for a lot of the mental models of how computation works, right? So it was a very natural thing to just say, oh, well, AI systems work like this. They're rules-based, they're logic-based, predicate logic-based, right? And there was also this bias in philosophy, right? That human minds worked like formal logic, like that was the pinnacle of thought, and reasoning and logic and predicate logic. If this, then that, was how the mind actually worked. And so it made sense that, well, we want computerizing machines to act like brains, and of course they're going to be logic-based, and they were called rules-based systems. So these begin to give way to a lot of more probabilistic and statistics-based types of things that are just looking at certain distributions for patterns and trying to kind of converge on patterns and data versus create these like massive rule sets of like, well, if you see this, then go this, and if it's this color, then do this, and if it's kind of a round shape, then maybe it's a coffee mug type of thing. And then the programming languages you get: MATLAB, Octave, R, S, Wolfram Mathematica, C and C++ have kind of always been there. Java got real big in the AI and NLP world, but probably also just because it got real big generally, right? And then Python, you see Python really start to kind of come up, especially in the early 2000s, mid 2000s. So other advances in computing.
So also. Josh,
yeah,
have you ever used MATLAB or Mathematica to do?
No. I
do not think Mathematica would do good at all, but I could see MATLAB working.
Yeah, so MATLAB's a big deal. Mathematica is kind of weird. I remember like reading through some of the manuals in college. I don't know why I was doing that. And I remember being like, wow, this is really neat and cool. But I don't know. Some of it's just kind of based on Stephen Wolfram's.
Oh, he wrote it. He wrote it, yeah. And still owns the company. So yeah. I used both of them extensively as a physicist.
Yeah.
And MATLAB is very much a computational mathematical language, and it's set up to hold numbers as what we think of as tensors. It's built for that, so it makes sense for machine learning. Whereas Mathematica doesn't have that concept.
Right.
It's, if you want to, it does great at symbolic solutions, which is really weird. And yeah, so it's totally different. Anyway, you put it up there, so that's why I was curious, because most people don't think of it, or they use it wrong, because that's not what it's for.
Yeah, well, and I think so like the Wolfram persona, right? Maybe the person that Stephen Wolfram wishes he was. I don't know. I don't know. Mathematica always kind of had this like enigmatic sense to it. Like, oh yeah, I can do this rules-based, symbolic, problem-solving stuff, right? But yeah, thanks for calling. Yeah, I'm glad you brought attention to that, because it is true. I don't know that it really ever like had got actual adoption. So, but it's worth noting, because it's, I don't know, it's kind of there in that world of when some of these programs.
Well, it's right. If you're just listing mathematically inclined languages, right? that are used for statistical analysis or mathematical proofs, you have to include Mathematica and MATLAB. Those are very, very heavy in the academic world. And what happens is universities buy license to one or another, but they don't do the same things.
Yeah, no, yeah. Yeah, and you know, I kind of skipped over the whole, there was this whole field of like formal proof solvers, right? And getting computers to solve math problems. And not only just solve math problems, but, you know, find new math problems, right? And in fact, that's kind of where Fortran came from, right? And so a lot of like early attempts or experiments in programming languages, right, were very much like, oh, we'll make it do some math, right? If it can solve math, it can do all this other cool stuff, right? And it turns out that's, you know, recognizing a coffee cup on a table is orders of magnitude, orders and orders and orders of magnitude much harder than solving some like differential equation for a computer. Turns out nobody knew that. But it turns right, so, but yeah. But the other interesting thing I think that you're pointing out here is that, yeah, they're like this class of programming languages here were very like adopted by like laboratories and like government funded laboratories, right? Drug laboratories, a lot of hard science like physics and chemistry. And these were built specifically, yeah, to represent data in a certain layout, computation, right? And so it would be more efficient. So you could do really, really fast, like,
numeric computations. It's for numerical computation.
Yes. Yeah. Yeah. Yep. So
sorry, that was, I didn't mean to.
No. So what's interesting though in the history of AI, right, is that there is, and this, I don't know, you know, how well this is advertised. It was a very fluid back and forth between what was becoming like AI, machine learning, natural language processing researchers, and then just computer science people. And the advances in computer science, all the way from hardware to software to the mathematics, and advances in how to automate knowledge or how to automate decisions based on data, right? Or how to teach a program to do something so that it has some function that it can optimize on. There actually was a lot of fluidity between these two, and everybody knows the one way that the AI benefited tremendously from a lot of advances in normal computing, right? And that's fairly well understood in terms of deep learning and neural networks. But what I think what gets left behind is that it was very much a two-way street, and there was kind of a lot of kind of intermingling, and it wasn't really that distinct as a I don't know. In the business world, it might seem distinct. I still think that in the academic world, you go and you find people who are just like, well, what? There's not really much of a distinction, right? We're all trying to solve these hard problems, and we're just kind of focusing on different ones. So early 2000s, this is where you get the rise of Python. And R and MATLAB really start to taking off. It's worth noting, if you've never worked with MATLAB, it is insanely expensive. You can spend up to $10,000 on a license. Like, deep learning, boom, takes off. Machine learning as a field, as like the probability and statistics-based, set of techniques. So machine learning is really just this umbrella term, right, for all these different algorithms and techniques that seek to do a very kind of similar thing, right? Like make process T optimize a particular function, right? And consensus. Here's the big thing, right? Here's where we start getting into, how does this relate to Go? Consensus around the tooling and techniques data sets, benchmarks, all of this starts to catalyze progress, right? Because instead of people arguing about, well, we should do it in this language, or do it in this language, or you should use my data set or that data set, because people start agreeing on particular tooling, they can now, pool sources, right? So matplotlib and pandas. Well, and they weren't really big projects when they started, but the point is, when you've got everybody kind of using everybody in the same wheelhouse, then you can benefit also from that expertise. And then, but then weirdly enough, in the early 2000s and up till now or so, I'm including up into the 2010s, you start to see languages like Go and Julia and Swift and Rust, right? Which are like, what's interesting, and these are all kind of a new take on some old programming languages, so to speak, right? And so let's say, all right, I want to build something today for ML and AI, right? Well, Python. I want to choose my tech stack. Okay, great. You can choose it as long as it's Python. And, oh, but we're a this or this shop, a Perl, Ruby, Node, PHP shop. No, sorry. If you want to use, the good, mature, fairly credible packages, you're most likely going to have to choose Python. Python wrapped around C++, by the way. Yes. Okay. AI is driven by research, not engineering. That is maybe, hopefully, starting to change. And so the choice of Python really is more of a historical accident, not really, I think, intentional. AI researchers weren't sitting around going, let's find the greatest programming language for doing AI. No, a lot of them really weren't even developers or professional developers. Some of them, like someone like me, wouldn't have even been included in the computer science side. And so it's even nowadays, ML, AI, NLP, it's all driven by research, right? Like if you go and look at the big names in deep learning and all that type of stuff, yeah, they work at private companies, but they're doing research. They're building tooling based on research, and so you see this migration out into private companies. Professors, right? They needed general purpose and easy to use tools. Python was starting to be used to teach more commonly. So here's kind of my story, is that grad students in university labs just use whatever their professors are using, which maybe is Python. And so they start doing a lot of the kind of free labor that ends up into these open source tools. Well, free, quote free. And then, of course, the students graduate, go out into the real world, or go teach at another university. And of course, they're not going to switch. Their job is research. Their job is publishing. Their job is discovering new algorithms. And so, so from a mathematical point of view, right, if you discover a new algorithm, it doesn't matter if it runs slow on Python, right? You just go and say, well, go implement it this way. And, the math holds, it should be much faster, given whatever constraints. But so the other reason for Python, right, it has a REPL. The type system doesn't really get in the way. And so it's a very easy language to both to learn and then to just kind of deal with in terms of this kind of fast feedback loop for experimenting and that type of stuff. And surprisingly, I don't know how many of you keep up with academia, surprisingly, it's still controversial to have people publish the code that their research paper is based on. It's like still a big deal. Some people defend, like, well, I shouldn't have to publish my code. My code looks horrible. And then the other people on the other side are like, that's the point.
Not in physics. Physicists always publish the code.
Good. Yeah, good. So anyways, Python just made sense. There was a lot of historical accident. I see it very much as like why JavaScript is in the browser and on the web, right? It's not because it was like, it had some appealing qualities that made it very easy to get up and running with and moving. And then that's just where everybody migrated and went with it. And it wasn't necessarily intentional, right? And the distinction there, which say something like Go, Julia, Swift, and Rust, right, is you start to see more intent in trying to carve out a particular area, especially with Julia. Julia, they are extremely specific about the goals of their programming language, which is basically to merge MATLAB, R, Python, and C++ all into like one thing. So what does it mean for Go, right? Or even Rust or Julia or kind of anything else? Because it's not really democratized, right? Like if you can get the expertise, you can get a service, but if you as a developer or as a small startup owner, right, are forced to then have to use a programming language you're either not familiar with or you don't want to use, that doesn't really qualify as democratizing, making it openly available, making it accessible, right? And so in terms of using other programming languages, and Go very much so, you're not going to be able to just go and replicate everything that Python has done. And of course, all the C++ work. It's just not a practical endeavor. So what you do, right, is you just want to capitalize on the weaknesses of Python. I'm picking on Python a little bit here, but the same thing is true for other languages of the same era as Python, right? Perl and JavaScript and Ruby, PHP. You've got a global interpreter law, right? Which is just, it's going to get in the way. You have a garbage collector, right? Which is going to get in the way. And so, Rust really kind of shines there in the sense that it doesn't have like a running garbage collector that you have to always be navigating. The async, concurrent, and parallel story in Python, while hopeful, it probably will never be, it's certainly nothing like what you'd find in Go. and Rust and Juliet have benefits there too that can be leveraged. If you're writing memory, high memory usage type of things, Go and Rust are really going to help there. I'm a little out of the loop with Julia these days, so I'm not quite sure like what kinds of memory constraints they're running with. Type safety, while Go isn't like Rust in terms of the kind of like guarantees that you get, it certainly is much more easier to deal with than Python. Type stability and multiple dispatch, that's very much a Julia thing. You can go look at that. It's a pretty interesting thing that Julia has found this niche, and they're kind of going for it in that. So, right, Go and Rust are pretty, I think, well designed to build like data processing infrastructure, which is probably not going to go away anytime soon. With the kind of democratization of AI and the access and the use, even small companies, medium-sized companies, now recognize the need and value of even if not doing ML, of doing analytics or other kinds of work on their data. It's just massive, the amount of data that you're using, that even small companies are using these days. The other thing too is it's often useful. So if you do have like say an ML team and they're running their big fancy TensorFlow or whatever model. But you still have to clean all this data, and you probably don't want to do it in straight Python, and you may not want to finagle with all these other kind of like weird, like Luigi and other kinds of things. Maybe it's just easier to do it in Go. It's probably not easier to do it in Rust. But often, right, if you're pushing data through, you can be collecting or even running certain calculations on the data as you're cleaning it or processing it, and then feed the result of those calculations or functions up as metadata downstream, right? And then you don't have to do a second pass over it to get that. So say you're processing sentences from SMS texts, right? And you just need to know the character count, the word count, and then some other counts, right? Like, well, as you're pulling that stuff out of the database and doing whatever with it to go send it, to the ML team and clean it and do all that stuff, while you're doing that, you've already got it. You might as well just do those counts and pass it on. And things, goes perfect for that. Like I said, it reduces the need to maybe go over the data again on certain things. And so having small ML capabilities, even if you're not doing this massive project, in languages like Go, Rust, even Ruby, all of them, right? It not only can it make it easier to do that type of stuff, but it then does kind of spread the wealth in terms of in terms of just the accessibility of it, right? So Postgres, you can do logistic regression in Postgres, right? Cool, who knew? There are other string.
I knew that.
Yeah, there are string metrics, string metrics that come native in Postgres, right? And I have used those. I've leveraged a lot of that stuff, and it's very, very useful to be able to when you've got the data in flight to be able to just do that at the time and pass it up. And while that's not a massive ML project, there's a case to be made that if you already have something like Go that's does very well with data processing, to have that capability. So that's all I got. I probably went way over time. I don't know.
I don't have time limits.
Oh, yeah.
Anybody have any questions? Okay, because I do if nobody else does. So do you think, Josh, in your vast experiences, do you think people are going to tend to want to stay to the Python, Nick frameworks, or do you think there's room for kind of people building more custom tooling closer to their tech stack?
Yeah. Oh, I think the need is there for sure, but
Siri was trying to tell me the answer to your question.
Oh, nice. Oh, I'd love to hear it too. By the way, Siri, the original Siri, she might not be like this now, but the original Siri was a rules-based system. Apple bought a kind of rules-based, sometimes they're called ontology, or a type of rule-based system that uses a lot of knowledge engineering, can be what's called an ontology. It originally, when Apple bought it, it was a rules-based system that kind of, didn't work so well. It still doesn't work too well. So I think the need, so it's kind of a chicken and egg type of thing too, right? Like, and I think that's where the more optimist side of the democratizing AI comes in. It's like, well, if the tools are there, then all you have to do is show people kind of how to use it. And when the fancy algorithm, right, is taken out of its mathematical form and put in code form for a professional developer, I have noticed and even for myself, it's often way more easy to understand. Like, oh, that's it? That's all it's doing? well, that's easy, right? Like, yeah, just loop over it and sum. That's all you're doing. That's all that means, right? And it's like, oh, it looked all like super complex. And so I think the need is definitely there. Once the tooling or some of the utilities get there, then I think there's kind of a bootstrappy, part of the momentum where people start seeing it, they start using it. But I mean, 10 years ago, I made this like wacky prediction. I was like, man, in 5 years, doing machine learning will just be as normal as like connecting, writing up a web server. And I was like so far off. It was like, whoa, way out there.
I have a follow-up. So do you think that as more software engineers start using, like, as machine learning starts to be more commonplace in industry or in private projects and less geared towards the research lab, do you think that'll kind of drive democratization? That's a yes or no question, but feel free to embellish.
Yeah, I mean, you can see that already happening in Go. You can see it happening in the JavaScript world. Of course, the JavaScript world is driven still a lot by Google's support for TensorFlow JS, but yeah. The problem, right, though, is just that kind of initial, collaboration, getting people together. And some of the mathematical software that needs to be written is often requires like a professional mathematician, right? Or somebody who is just really naturally is still super familiar and naturally gifted mathematician, because you want professional mathematicians building, like like I'm thinking of GoNum, right? And like the people who have been building GoNum, like those are people that you can trust. If you go and you look at what they do.
Physicist at CERN.
Yeah, and you look at their job and you look at their background, and you're like, okay, I think I believe that guy when he says, no, this is the proper way to implement this statistical distribution. And you're like, okay, I believe you, right? And so that's like the big blocker, right? Some of those really foundational math packages that need to be there. There is some benefit you can get from like wrapping existing C or C++ libraries, and that's where Go kind of like the C Go story is really kind of lacking.
That's what Python does. I don't see any benefit. Personal opinion.
Yeah, and for other kinds of things, and so Julia made it a target to be able to wrap C++ code very well. Rust does that very well. Swift, I think, does that pretty good too. And funny enough, so Google, if you're aware, Google a couple of years ago, they kind of came out with this big announcement at one of their TensorFlow conferences, and they said, hey, they didn't put it this way, but I'm going to put it. They said basically Python is not good for doing this stuff. Even though most of it is just wrapping a lot of these C to Fortran things and other kinds of in C++ libraries, and so it's just calling out. So like, if you had a Julia program that needed to call this Fortran stuff, you're going to get essentially the same speed, right? Effectively, especially if you're looking at like 6-hour training time. So if you're only making one call out to the C stuff, then in 6 hours, what that's nothing. So Google decided they were going to be like, okay, we're going to go off of Python, because they were noticing that too much straight up Python code was being written and too much stuff was happening in Python. And not in the C++. And so TensorFlow suddenly became this big, like, sprawling out kind of monolith. And they wanted a language that was more suited to the needs of TensorFlow specifically. And so they had this whole document. They evaluated C++, they evaluated Go, They, well, shortly evaluated Go. They evaluated Julia and Rust and Swift. They narrowed it down to Julia, Swift, and Rust, and then they picked Swift. And it probably wasn't a surprise because Chris Lattner, who created Swift and came from Apple, had already been hired to be on the TensorFlow team. And so everyone was kind of like, oh, yeah, okay, sure, yeah, of course, that's why you picked Swift, duh. So, you know, that to me was like the big message from the enterprise world to say, oh yeah, we recognize that, you know, while in this stage of like, say, early startup hypergrowth, Python has served us very, very well. For the next 20 years, we probably want to do something else. But I don't know, you know, I think the Swift project has kind of like lost a lot of momentum.
Cool.
So, yeah. But,
any other questions? Go ahead, Josh.
Yeah, you've been in the Go world long enough now, and you see the amount of work and effort that goes into just getting, sometimes even just some of this basic stuff. It's, you know, it is a bit of work, and and so you have to be very, you know, for a while I was involved with some Rust ML stuff, and you have to be very strategic about, you know, what you want to tackle, what parts you want to do, because you don't want to go in and just try and re-implement everything Python did, or that C++, there are packages that already exist. So you want to try and fill that gap, or do it better, right? But still, you know, I mean, if you're a full-time developer and you do this stuff as an open source project on the side, it's not going to work for you. It's not going to happen. So I think enough people see that you know, the Python has and still is serving us well, and it's not going anywhere. Python is not going anywhere. It's already kind of chewed away a bit of the market of R, or the person base of R, like how many people use R to do stuff. But Julia is actually, you know, Julia probably is the next kind of up and coming big competitor to, and not directly with Python, but in what's called the science ML world. So scientific machine learning, so differential equation solvers, and there's a lot of reasons for that, for why Julia, both just kind of as a historical accident, has probably what are now the best cutting edge differential equation solvers, but then there are also some reasons because of the language itself. And so what you see is, as people are trying to move off or move away from Python or even Lisp, some of these Prolog, even some of these older versions, is you're seeing a much more more focused and intentional decision to say, we're going to use this for this and for this domain. Yeah, so I think eventually it will grow out, and it will happen, and it will the stranglehold. I mean, to me, it's a stranglehold because I don't use Python every day, and I don't really want to. I never really actually liked the language. It was never intuitive to me. I'm sorry, but white space as a delimiter between all this, people were like, it's so readable, and I was like, what? Something's wrong with me then. Yeah, Curtis says yes. Stupid idea. But yeah, I mean, I think the idea isn't to like beat up Python and re-implement everything from Python and beat that out. The idea is to start migrating where it makes sense some of this core functionality into other ecosystems, right? Because then whether you're a Node.js shop or a Go shop, you know, or you're using Swift, or whatever the case may be. You have accessible to you some of the foundational packages that you need. So in the Go world, it still very much is like a build your own. There's a lot of like, you know, DIY kind of do it yourself type of stuff, but you know that, you know, that's kind of a two-edged sword, but depending on what you're doing, it's not that difficult, I think, often to gain the expertise, especially if you're dealing with people who are already professional developers. And then to say, okay, well, you know, we have GoNum, which is an awesome statistics package, so let's go and like build something. And I've done that. I've built stuff that you know, it wasn't using scikit-learn, it wasn't using all this stuff, it wasn't like doing this big like neural network thing, but it was doing like these kinds of heuristics that were similar to what a neural network kind of does. And so, you know, if you have the fundamental stuff, you can start building that out and building small projects to do small things with the fundamental packages that exist. So it's hopeful.
Cool. Any other questions? Awesome. Thanks, Josh.
Yeah.
I love machine learning to go, so you made me happy today.
Yeah.